So if we try to see, so if we just go to our understanding of our curriculum,
Mm.
so this is clear to you, right?
Yes.
We have done this part also. We did some of it last times, right?
Yes.
Uh, Now you like when you look at it now, you have an understanding how the data maybe or how to get it from the internet, right?
Yes.
Okay. So we will just as a concept of remote sensing basics,
Mhm.
think of satellite sensors bands. So in satellites, there is also this part, the satellite orbit, the GPS system, the GNSS system.
Mm.
So we will today talk about it a little and we created NDVI, right? Once.
Yeah. Yes.
Did I give any homework or something, anything?
No.
No. Okay. So probably today we will wind up this all
Okay.
and most probably in the next class
Mm.
we'll start with the basics of SQL. So
Okay.
SQL is important. Do you have an idea, like have you worked with SQL before?
No.
Okay. So we will do first a lecture about
Mm.
understanding how, like, what is SQL, how it works, because
Mm.
this PostGIS, Postgres, this will come after you understand the SQL.
Okay.
So this is like a prerequisite to understand this all.
Okay.
So basically, what I mean to say is to learn Python, you need to first learn English, right?
Yes.
To do this all, we need to first learn SQL.
SQL. Okay.
Okay. So what these terms mean, you don't need to worry. You
Okay.
just be prepared for
SQL.
understanding the
Yes.
SQL part.
Okay.
So once you get into SQL up to a certain level,
Mm.
then we go to understand what these terms mean,
Okay.
and then we try to understand how we are using SQL in them.
Mm.
Okay.
Mm. Good.
Uh, Just a minute. Okay. CPS. So, have you ever seen such instruments? They are used
Yeah.
to detect
Yes.
the GPS.
GPS. Yes.
History is not so important in GPS, but if you want to understand, the studies began in
Mm.
1960. First GPS satellite was launched in 1978, and the first properly fully functional GPS system was launched in 1995. So
Okay.
until before 1995, getting your proper location was a big problem.
Mm.
Now, what happens is the broad term is GNSS,
Mm.
not GPS.
Mm.
GNS is something, there is subparts to it called as these four. But
Okay.
GNSS means is Global Navigation Satellite System.
Mm.
Now, what happens is if you have one satellite in the orbit,
Mm.
uh, maybe before going to GPS, we'll cover this one thing. I'll share this link also with you for reference and future reading. So when we are placing the satellite in the orbit,
Mm,
so they are placed in very different uh, orbit, like one is near Earth, one is far Earth. So their distance from the ground is also basically the application of use. Like if it is here, we use it for some other reasons. And how it moves in the orbit is also what defines what observations it can be useful for.
mm,
Okay. So what are the different types of orbits where we
okay.
can place the satellite? So the most common ones are low Earth orbit,
Mm,
medium Earth orbit,
mm,
geostationary orbit, sun
mm,
synchronous orbit, geostationary transfer orbit.
okay.
So these are the ones you should know.
Mm,
Other than this, if you are going, that is your extra study, but this you should know by heart.
okay.
Now, uh, for example, we first talk about the low Earth orbit.
Mm,
Now, if a satellite is placed in between 160 kilometers to 1500 kilometers,
mm,
like from Earth, it is placed to 160 kilometers to
160.
50,
Mm,
1500 kilometers.
mm,
So that satellite is classified into the low Earth
no,
orbit.
that's okay.
But you will be just give me a minute. I'm getting a call.
Okay.
Sorry about that. So we have when the satellite is placed in 160 to 1500 kilometers, it is called as the low Earth orbit. Now they have very short period of travel. Just try to think. It can complete the orbit in 90 to 120 minutes. That is between 2 to 3 hours. Hello. Asad, am I audible? Hello.
Oh,
Hello.
sorry, I thought my
Okay.
speaker was mute. Sorry.
Okay. No worries. So, like, uh, the satellite in these orbits can travel around the Earth in just 90 to 120 minutes. So
Yes.
that is like it goes around the Earth 16 times a day.
Mm,
So that is too much, right?
mm,
So they are used for different applications of remote sensing because it is near to Earth. The more it is
yes.
near, so it can take very high resolution images of Earth.
Mm,
And because maybe if I want to make an observation at one point many times a day, so
mm,
these satellites are used to make observations, like frequent observations if there is something like a forest fire or something. So such
mm,
a satellite can be used to do frequent observation
mm,
to check the extent, and so such is the application. Now all these type of satellites in low Earth can vary at an angle of their plane too. So it is not a defined plane. It can be at an any angle, right?
mm. So
But
it basically moves at one location or it also
no,
changes
no,
its speed?
it can be any. We have
Okay.
just defined the altitude. It can be
Mm,
like this. It can be like
okay.
this.
Okay.
So it is not restricted to any particular orbit.
Okay.
Now there is a downside because we are working very near to Earth,
Mm,
so it is not able to cover that much. If the satellite was far away, it will have a more wide angle, right?
mm, mhm,
So the coverage, they have smaller coverage.
mm,
Then comes the medium Earth observation satellite. Now, if your altitude is something between 5,000 to 20,000,
yes.
so you see that it can be called as medium Earth observation satellite. You can see the orbit can be like this, anything. It can be anything. So these are mostly used for your positioning of navigation satellites. Your
Mm,
GPS, GNSS, and all the three, four types that we'll study, all
mm,
of them are mostly placed in medium Earth orbit.
yeah, orbit. Mm,
Okay. So they take around, uh, to complete one orbit around to Earth, they can take between 2 to 12 hours.
what? Mm,
Whereas for that, it was just uh, 90 to 120 minutes. For here,
mm,
we have at least 2 hours to uh,
12.
12 hours.
Yes.
Then we have the third type, that is the
J.
geostationary orbit.
Yeah.
Now, what happens in such a orbit is, for example, we are sitting here and you want to have a satellite that does constant observation of this area, constant.
Mm,
So, for example, I placed a satellite here.
mm,
It is looking constantly here
mm,
and it is moving with the same speed as of the rotation of the Earth.
mm,
So, it can do constant observations.
yes.
So, in this case, the speed of the satellite is similar to the speed of
Earth.
Earth.
Yes.
Now, this is one of the very important satellites. Why? Because every country needs their constant observation. So,
Mm,
such kind of a satellite is highly used in meteorology. So, just to have a understanding of their weather patterns, to
mm,
understand their current pattern at all the times.
mm,
So, meteorological satellite will be placed in a geostationary orbit.
okay.
Now, because now, for example, what it says is, if I place one here, and one here,
Mm,
given their distance from the Earth,
mm,
because they're so far away, you just
mm,
see the that this was just 5,000 to 20,000, this is 160 to 1,500.
mm,
Given that they are so far away,
yes.
if there are three GE, if there are three satellites placed in such an orbit,
Mm,
they can cover the extent, like not the upper, maybe, but they are possibly able to cover almost the all Earth,
mm,
right?
yes.
So you read here, three evenly spaced machines in the GEO can give nearly
Yeah.
worldwide coverage.
Mm,
Now, for example, I am a spy, maybe USA. I'm USA, so I can place three. I can place as many as just, but it is so simple for me to just place three GEO satellites and observe what is happening all around the world constantly,
mm,
right?
mm,
And they might be doing it also.
mm,
So any country can just like three is nothing. Like I think many countries might be having so many satellites, GEO,
mm,
just look over the other countries, right?
mm,
Yeah. So, for example, if you are moving in a car, this is a
mm,
car. Now, you are this person, you are going ahead with a speed of 60.
mm.
Now, if there is another person sitting here, so similarly, he is also going ahead with a speed of 60 only.
Yes.
But to both of you, if you look at each other, you will appear stationary
Yes.
because the relative speed is zero.
Yes.
So similarly, now the satellite is moving as the same speed of the Earth. So to
Yes.
any observer on Earth, it will
Mm.
always appear to be constant.
Constant, yes.
So it takes 23 hours, 56 minutes and 4 seconds to orbit around the Earth.
Mm.
Now, why for some cases such satellite are perfect? For example, our mobile networks to work, for our TV and phones to work, this can provide constant communication service,
Mm.
right? Because it is constantly analyzing, so it can provide constant communication service. Also, they are highly used in meteorology to keep an eye on the weather in in
Regions.
particular regions.
Mm.
So the downside of such a type of machine or the satellite is uh, because it is like far away from Earth, right?
Mm.
Whereas if it is like if there is a satellite that is so near, the
Mm.
signal will go and come back very quickly.
Yes.
But here it will take a longer time.
Mm.
Though the delay would be in microseconds because the signal moves at a speed of light,
Mm.
but in theory there is a delay.
Mm.
So if you are working with many, for example, if you are working with something and you need high accuracy,
Mm.
so that delay will uh, cause time error, like it will cause other kinds of navigational error. That delay uh, of signal, maybe it is in microseconds, but the error, though it might be negligible, but it is more than the other orbit heights.
Yes.
So there is this question, what type of satellite is used to monitor cloud cover?
Okay.
Satellites in geostationary orbit provide observations of cloud patterns that are used to calculate wind speeds.
Mm.
Okay. So how do you know wind speeds? Because you calculate it from the cloud itself.
Mm. How do you move?
Huh?
By getting the pattern of cloud cover, like how they are changing.
No, no. Now this is a cloud.
Mm.
It moved in this direction.
Mm.
So you will average it out, take a center point,
Mm-hmm.
and this is also like not so ideal mathematics. There must be rules to it, but you take the center point here again. So now the time it took to go from here to here, you're
Yes.
constantly observing it. So you
Mm-hmm.
know the time it took to go from here to here by the speed.
Mm-hmm.
Sorry, the distance by the time. Now you have the speed.
Mm-hmm.
So you
Got it.
know the wind speed and wind direction from this.
So this there's a sensors that are installed into the satellite, or there are some different AI models or something like that.
Manually, no one will be doing it. I think
Mm-hmm.
there is just AI models that will just see a particular cloud and understand its movement and just give the system the speed and direction of the wind. I don't think so. Manually, it is done now.
Okay, so the wind direction we get in the usually weather apps are from the geostationary satellites.
No, so there are two kinds of data.
Mm-hmm.
So one data is from the uh, sensor on the ground.
Mm-hmm.
So generally, if you see, like if there is a sensor down on the ground that can also detect the wind speed and wind direction, so it is not particularly that the case it is calculated from the satellites only. They are, I think, more dependent on the ground sensors because it is not so much expensive, or you can say it is more easier than observing them from the satellites, right?
Yes. Or maybe the accuracy is more high here.
Yeah, because you know the exact speed of wind, right?
Mm-hmm. Mm-hmm.
Whereas um, then there is sun synchronous orbit.
Mm-hmm.
So in this orbit, for example, this the satellite was here at this point at 4 p.m., right?
Mm-hmm.
So every day at this time, it will be here only.
Okay, same location.
Yeah. Same time, same location.
Same locations.
So the sun synchronous orbit type of satellite goes from north to south
Mm.
across the polar regions. So it is always north to south. Okay.
Yes, yes, yes,
It can
yes.
be a little like this, but it is always north
North
to
to south.
south.
Yes.
Yeah. And you can see it is so near to Earth.
Mm.
It's just 600 kilometer to 800 kilometer.
Yes.
So uh, they are used for Earth observation monitoring because they are also very near to Earth. They can take very high resolution images, right?
Mm.
So mm, you can say one thing is this is the sun synchronous orbit
Mm.
is a subtype of low Earth orbit only
Yes.
because it's 160 to 1500. So it is 600 to 800.
800, yes.
So it is a special type of case of low Earth orbits where it is precisely has to be at the same place on the same time and is
Mm.
moving from north to south.
Yes.
Then there is this one special case that is called as geostationary transfer orbit.
Mm.
Just a moment. Let me get water. Okay. So we studied about geostationary satellite.
Yes.
Now what is this? So when you launch a satellite and at the very moment that it reaches the trajectory
Mm-hmm.
that it will follow and join this geostationary satellite, that blue part of that trajectory is called as the GTO,
GQ. Okay.
geostationary transfer
Transfer.
orbit, because you're transferring it to this orbit.
Yes.
So until here, you are maneuvering it using different kind of uh, like you have these air like gas engines to maneuver the aircraft. So
Mm-hmm.
you maneuver it until here, you release all the weights, but once it enters here, then it goes in such a manner that it is placed in the orbit. Now, uh, this how to explain this? This is just a transfer orbit. It is just to understand what it is. So there can be some particular application for this, but it would be one time only, right?
Mm-hmm.
So for example, it is going from here, and at that one moment, it can capture a certain kind of imagery or something. But it is just talked about or studied just to understand how it is used to place the satellite into the geostationary orbit only.
Yes.
Okay. Now there are some other very less common type. You can study it if you want. That is highly elliptical orbit, polar orbit, and Lagrange point.
Engage point.
Yeah, but they need not to be studied. But if you want to go deep into the orbits, you can have a look at it.
Okay.
So I've already shared this link for your reference, right?
Mm. I got it.
Okay.
So just a question like this Sentinel-2 or Nansat or any commercial type of satellites, which orbit they follow usually?
I think they are in medium Earth orbit,
Mm-hmm.
Landsat, orbit, satellite. Okay. It is a sun synchronous orbit. Okay. What
From
about,
north to south,
yeah, what about Sentinel 2?
lower
It is
orbit.
also a low Earth orbit. Yeah, because just try to understand that we are using images from it, right?
Mm.
So we need high resolution. So they are always these ones.
But still, the resolution of Sentinel-2 is not that
Hmm?
up to, it's 10 meters, something like that.
Yeah, it is 10 meters.
Yes.
So
Mm.
both of them are low Earth orbit.
Yes.
So mostly all the GPS ones,
Mm.
the one
Galileo.
used to understand the location, are in MEO.
Okay.
Yeah. Mm, so meteorology one is in geostationary one, right?
Mm. Mm.
Yes.
So these are also commercial one or these are also for like private companies on this?
So, like GPS was by America, so they launched it, but they made it open use. Like, but
Okay.
some countries still like they have this for their own country, but
Mm.
USA gave the world a system for free GPS.
Mm.
So, sun, synchronous, right?
Mm.
Okay, then Landsat and Sentinel-2 are both low Earth orbit and they are sun synchronous. So, good to remember. Now, after this, we talk about the GPS systems.
Yes.
Now, what happens is, so we have something called as GNSS. Now, that is Global Navigation Satellite System.
No system, yes.
So, this is a constellation of satellites. It is not one satellite, it is not two satellite, it is not three satellite. It is a constellation of satellite.
Mm.
So, GPS was developed by USA, whereas GLONASS was developed by Russia. Then
Mm.
Galileo was developed by the European Union.
Mm.
And then Compass, which is also now called as Baidu, was operated by Chinese government.
Um,
So they are kind of the main for global navigation because global means you are anywhere on the planet and they can help you get your location. So
mm.
GPS is available free worldwidely and it is so much used that no one knows the word GNSS.
Mm.
Everyone knows just the word GPS.
GPS.
So the mechanisms is same, but the wide usage of GPS has made it more common.
Mm.
Then India has its own system, but it's not a global system. The
Mm.
system it is more of a regional or local system. It can help you understand your location in India, but
Mm.
not around like in India and Asian countries, yes, but not around the globe. So it is not classified into GNSS.
Global system, yes.
Yeah. So you see now there is so many satellites that help you
Mm.
understand your location. But why do we need so many satellites? So the
Mm.
GPS system includes 24 satellites and the number has been decreasing over time. So I think with coming time it will only increase with
Mm.
okay.
But how they do manage like in space if there are so many satellites out there?
Um, if you see that maybe this is a 100-kilometer road on ground,
Mm.
100 kilometers,
Mm.
and I place 10 cars,
Mm.
10 cars per 10 kilometer, I think.
Yes.
So one car in 10 kilometer. Can you say that this road is kind of will you say that it is trafficked or will you say it is almost nearly empty only?
I guess it's almost empty because
Yeah.
all the cars are moving from 10 kilometers per hour.
So similarly, the orbit of Earth, this is uh, the Uh, So it is 40,000 kilometers.
Mm,
So if in 40,000 kilometers, that is the circle,
mm,
if you place 1,000 satellites or 5,000 satellites, it is not crowded. To get it
mm,
crowded, you have to place like 1 or 2 lakh satellites. Then
mm,
also it may not be crowded.
yes.
So there is place for every satellite. It is not crowded.
Mm,
Uh, I think hardly, what is the total number of satellites in the space? So just 13,000.
mm,
It is nothing.
mm. But like I guess Elon Musk itself launching 100 something satellites as well into the space.
Yes, yes.
Mm,
So there are many private companies. Amazon
mm.
has its satellites.
Yes, Amazon, Google, I guess also trying to do something as well.
I think Google already has many satellites. I think
Mm,
uh, satellites by Google placed in mm, satellites by Google placed in space. Okay. So
yes,
Google does not have one yet, but it
I
is
think
planning to have
yes,
something.
yes, like Max are a commercial one,
Yeah.
not for the open source projects.
Then, uh, why do we need so many satellites? The reason for it is, now I will explain the theory. So, mm, so this is the Earth and this is the satellite. Now you are standing with your mobile phone here, right?
Mm,
Now what this satellite is doing, it is sending a signal to your mobile phone. That satellite has sent a signal to your mobile phone.
mm,
It came, it reached, and then it went back.
yes.
So that signal took, it was working with the speed of light. So maybe it took t time.
Mm,
So this distance the signal traveled, went there and came back.
mm,
That is CT. So that means this distance is CT by 2.
yes.
Now, because you are sending a signal and you are getting a signal,
Mm,
that is just a signal that will give you a data. So based on that data, based on this value CT by 2, this is a distance, right? So based on this distance, it will create a probability of sphere that you are anywhere, maybe if you call this distance x, that is ct by 2. So
mm,
according to the satellite, you can be anywhere on this plane, on this sphere of probability.
Mm.
That is that you are X distance away from the satellite. Got the point?
Yeah.
Right?
Mm.
No, I'm asking if that thing is clear to you.
Yes, yes, I got it.
Okay. So similarly, now if I have one another satellite here,
Mm.
now it also sends you a signal. Now it also sends you a signal.
Mm.
That signal goes to you and comes back.
Mm.
So maybe the distance of this satellite was different from that satellite, right?
Yes.
So it will create its own probability of sphere
Mm.
that you are at y distance from it.
Mm.
According to this satellite, you could have been anywhere here,
Yes.
right?
Mm.
Uh, okay, so I made it a little wrong. Uh, So according to this satellite, you can be anywhere on this sphere. Now what
Mm.
happened is, before, if you had just a single satellite, your probability was you could have been anywhere.
Anyway, in this position.
Now when you had two satellites,
Mm.
your probability narrowed down to this zone
Mm.
that when two satellites are working together, they gave two circles,
Mm.
and now you know that you are only here, you are among
Mm.
this area only,
No.
right?
Mm.
Now, what happens if I give you a third satellite that is viewing you from here? Sorry. If I give you a third satellite that sends to you, so this will also need we move? No. So this will also create a sphere of probability.
Mm.
So you will be narrowed down to a single point.
Mm.
So this method is called as triangulation method.
Mm.
Now your location is of a single point. Now
Mm.
you know why need more satellites, right?
Yes, 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 yes.
So at any time of those satellites, maybe if three of them are working, they are able to give you a location. But
Mm.
this is in 2D.
Yes.
This is what I explained you in 2D. In 2D, this is called as triangulation. But if
Okay.
you see, Earth is not a circle, it is a sphere.
Sphere, yes.
Similarly, this this will not be a probability of circle, this will be a probability of sphere.
Sphere.
So you can be anywhere on that sphere.
Mm.
So it will form three spheres.
Mm.
So when three spheres will interact,
Mm.
they will again not form a point. They will form a zone
Mm.
that will give you one line. So you still can either your probability can be your here, you can be here, you can be here, or you can be here
mm,
because they are 3D. So if it was not a sphere, if it was a just a circle, then you're narrowed down to 1 point. But
mm,
because they are sphere,
mm.
you still get then to finally get to 1 point, you have one more circle. That is the fourth satellite, right?
Okay. Mm,
So then you get exactly 1 point. So in case someone asks you what is the minimum number of satellites to find your GPS location, so it is four,
oh,
right?
yes.
Uh, so if you say okay with three, then there will always be error. So even with four also you see that because the signals, the positions and things are not so well established that still we have errors.
Mm,
In mobiles we have like 3 meter error, 4 meter error,
yes.
but still we have errors. So
Errors.
more the number of satellites looking for you, more
Mm,
less is the error. I mean, if maybe six satellites are looking at you, then the error will be less, but that is not the case because at a time only four satellites are there are maybe 24 satellites in the constellation, but depending on your region, only
mm.
four are working at a time to locate you.
Okay. So for example, if I like search for a location in Google Maps, so
Hmm.
at that time, four satellites will catch that location or catch that point.
Yeah.
Okay, perfect.
So number of satellites in GPS, GLONASS, Galileo, and everything. So as of today,
Mm.
GPS has 31 operational satellites.
Yes.
Galileo has 30 operational satellites.
Mm.
Baidu has
35.
35. So we read one name here. That was the Russian one. No, GLONASS. So GLONASS has
24.
24. So wherever you are, so these four GPS, GLONASS, Baidu, Galileo, they are GNSS system.
Mm.
QZSS and IRNSS is local.
Mm, okay.
They are not GPS, the GNSS.
Mm.
Mm. So if we don't have a constellation of satellites, we cannot get our location. So you see, when you are maybe in a place where there are a lot of trees,
Mm.
so the trees are breaking your signals. And like what I will edit what I said before. To locate you, at least four satellites are working. Like number of satellite signal can increase. Maybe six are working to you, locate to
Mm.
you. But it depends on your location and availability.
Yes, and the more accurate will be
Yeah.
the
So for
better.
example, if you are somewhere in forest area, so signal will get reflected. Satellites are not able to connect to you. So you'll get more error.
Mm.
Then we next talk about one thing that is called as. Now this is clear to you, right? How GPS works.
Yes. So at a time, many persons can use the satellites for
Yeah,
navigation.
yeah, yeah. The whole world can together use it.
Mm.
Because signals, they can produce lakhs of crores
Yeah.
of signal in one go.
Okay.
So then we have something called as differential
Mm.
GPS. Uh, what happens here is you see in DGPS there is two components. It is made of two components. One is like a mobile that you are placed having in your hand, and the another is this heavy thing that is placed on a tripod.
Mm.
So what DGPS does is it gives more accurate values. Now
Mm.
how it works is, for example, you are standing here with the one component of DGPS that is just like a smartphone,
Mm.
and you are standing here on the ground, and here you place your DGPS on a tripod, the other component. Now you are working with something that you need very high accuracy. For example, you are marking the plots for someone house that you are, if two people have plots, you are the revenue person, you have to plot it very accurately so that the house is marked properly, right?
Mm.
So maybe in that case, for example, you will work with the DGPS. So
Mm.
what happens is this part of DGPS, it is fitted with, it is already fitted with a like a data model of Earth. Like you can go and select different datums. So it knows its location on Earth already. So no, it knows its lat long already. Um, so it knows its lat long already.
Mm.
Now what happens is, because this is so heavy, you cannot just pick it up and mark everywhere, right? You use the other component of DGPS. Now what it does is, when you were moving around this plot with DGPS and you took reading here, you took reading here, you took reading here, what it does is the satellite connected to you, it gave you a lat long value.
Mm.
Now, with reference to the distance here, they both are connected. Now, it knows according to its location that here the value should have been x and y,
Mm.
but the uh, sorry, the satellite has given you, the satellites has given you the location x and y
Mm.
by, but according to this, your value should have been a and b. Now you know x minus a and
Y minus B.
y minus b is the error in your lat long.
Mm.
So wherever you are taking the values, you will delete, you will, this will, the DGPS will give you a and b. And
Mm-hmm.
wherever you are taking the value now, you will delete A and B from it, right?
Mm-hmm.
So now you have more accurate locations, positions. So this is how DGPS works. So there are like ships and everything where only this component is placed because it is very heavy and needs time to calibrate and work. It needs to be stable. It cannot be moved around. So though it is placed on it, it alone is also placed on the flight, aeroplanes, ships. So it can work alone also. But if you are working on the ground, it is given a stable condition and it locates itself accordingly. And then your location with the DGPS, then it tells you, okay, you are at this much error.
So just a question, how does he know stay in that long, the DGBS?
Uh, so you remember the geographic coordinate system, the projected coordinate system, right?
Mm-hmm.
So we have already created those systems now.
Mm-hmm.
We have a 3D model of it in our computers. Like we have already created them. We just feed it into this.
Okay.
So it kind of knows where it is on the planet. Like, um, how to explain it?
So I just okay, so he the idea was, for example, if I have like 30-degree south and 45-degree north, something like
Mhm.
that, and we just put it in the DGP in the this machine, right? That specific coordinates.
No, 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 no. Uh, DGPS is for accurate points. Like if someone tells me I have a plot, this is my agriculture field. I
Mm-hmm.
just want you to go and make this plot take locations that long at every
Mm-hmm.
point and give me a boundary of it.
Yes. Yes. Yes.
So with the help of DGPS, it will be more accurate as compared to with a mobile phone.
Yes, that is.
So I will go and with DGPS, I'm able to get all the lat long of the values.
Mm-hmm.
So maybe what we could do is we could ask Google is maybe the main component is also working with satellite only, but I don't think so. How does the main component of the DGPS knows its location? See,
Hmm. Okay. So it automatically is done manually.
yeah. So like someone created like you just read here
Hmm.
centimeter level accuracy
Hmm.
and it is fed into it.
Hmm.
So we are done with the concept of DGPS and GPS and GNSS, right?
Yes.
Now we will maybe. So let's perform some raster and vector operations. Okay. Do you have your ArcGIS Pro working? Hello.
Yes.
Okay.
Oh,
So go to your ArcGIS Pro. Open a new project. For example, yeah, write on Google Viva GIS. Choose the link where it is written Data Diva GIS. Now you select for country for own reference. For example, I choose India. You can choose any. Just choose your country and then look if there is administrative areas. Yeah. So just choose the area and click download here.
Okay.
The file will download. Did it download?
Yes.
Now extract the file. So after extraction, just select all,
Mhm.
maybe drag it into your ArcGIS. Will take a little time to load maybe. So were you able to add?
Yes.
Now what do you see if you I'm seeing, do you see something like this?
Mm.
There are other layers also maybe. Mm.
No, for me, it's only CSV, CSV, CSV files.
Okay, do one thing is just remove this. Now go to project, sorry, not project, go to map.
Mm.
In map, click add data. In this add data, just select the folder where it was downloaded.
Okay.
In this folder, uh,
Yes.
you select 3, 0,
All of
1,
this.
2, 3, just like this one. The one with admin 0, 1, 2, 3. You select all these.
Mm.
and you press OK.
Yes, now it's open.
So if you push one layer over the another, you can see all layers,
Hmm.
right? Now, just for example, let's go to USGS.
Yes, yes.
Look for any where like I have downloaded the file for here. Look for any zone. Just go and click use map.
Hmm.
Just take a small zone. Go to datasets. Do not
Hmm.
select date. In dataset, go to elevation model. And in elevation model, go to SRTM and select this SRTM 1 arc second and click on results. So it will give you probably many results of the area, right?
Okay, just downloading it. Hmm.
Opened.
Just a minute. Digital animation, STRR. STRR, 1 second. Results. I have to download any one. I have seen two datasets.
Okay. Now look for the one that is showing you more this white thing.
Okay, for
Or
me,
are both of them black?
both of them are black.
No worries then. Just download one of it. You click
Okay.
download here.
Now, define GeoTIFF, which format?
Always GeoTIFF.
TIFF.
Just let me know once it's downloaded.
It did not download. Oh,
Did you click on the GeoTIFF download?
yes.
Did it download?
Okay, now it started.
Okay. Just let me know once it's downloaded.
It's download now. I have selected the small area. Is it fine or?
Huh?
I have selected a small area.
No worries, no worries.
Okay, it's downloaded now.
So now have you ever downloaded digital elevation model before?
I guess not. No, this is my
So
first
now
time.
you know how to download a digital
Yes,
elevation model for any area, right?
yes, yes.
Okay.
Should I have to upload it or?
Just a moment, I'll tell you. Now, Mhm. Now, you go and extract it. You have to extract it uh, to your downloads. Just extract the file. It will, or is it okay? We downloaded TIFF, so it would be like this, right?
Mm,
Now, you just drag one of it, like you just downloaded one. You just drag it into the ArcGIS. Is it showing like this?
yes.
Okay. Now, what this is a digital elevation model. So, for example, if I click anywhere, I know the height above the sea level. So it is 288 meters above sea level. So this white thing is like it is going towards mountains. So,
Mm,
if I click here, see 1400 So it is Himalayas on this side. So if I download something from here, it will be like 3000 something.
mm,
So you have this is the elevation profile of the region. The highest point in this rectangle is at 1915 meters. Uh, or is it feet? 300 meter. Yeah. Uh, it is meters only. Okay. It is not meters. Uh, don't see. No, centimeter of sea level measures. Okay, so it is meters only.
mm,
It is meters only. Mm. Now, for example, if I am working with this administration boundary in my area, I look for this ADMN2. I click here and I just simply select a black outline, ADMN2. And this I select a black outline and then in properties, I change the black to maybe pink. Okay. And then I move it above it.
symbology.
Hmm?
Okay, I'm trying to do that as well. Symbol, symbol.
Pardon?
You just right click on symbology?
Okay, I'll do that part again. So what you do is you click here.
Open the box.
When you click here, this will appear. So in color, I select no color.
Mm,
In outline color, I select any color other than black, any bright color. Maybe I then change it to 2.
okay.
Done.
Yes.
Then I move that layer like this
Okay.
above this layer.
Okay. Okay. Done.
Done. So Do you have any polygon that is completely falling inside the black area?
Yes.
Okay. So you just click on it. You can look for name 2. For
Name
me, it's Fatehgarh Sahib.
for me it's Gautam Bhuttanagar.
Yeah. So what you do is you go right click and you go to attribute tables. And here you go for this is Punjab state. So I know this is I look in name 1 for Punjab and in MNOP. So in Punjab, I look for Fatehgarh Sahib. Here it is. So when I select it, it gets selected. Were you able to locate?
Yes.
So when you click it, is it highlighted like this?
Yes.
Now what you do next is you,
I just select the feature.
huh?
I just select the feature as well. Same one.
No, no. When you selected it, is it highlighted like this?
Yes, yes, yes. Like I use a different way. Like I go to the map and then I use the select feature.
Ah, okay. Yeah, no worries. So now you just go right click here
Mm.
in data,
Export.
export feature.
Yes.
Make sure this is turned on.
Mm.
Now I extract it. So I will close my this layer. Now I just have this one,
Mm.
right? Did you
Yes.
get to this point?
Yes.
Now, for example, I want the below layer, but I want to do analysis for my region only.
You can use
So there is this something called as when you go to analysis and you click tools, in analysis you click tools, you just right click here. So maybe just select this one, clip raster. Okay.
Mm.
In the input raster, select your this digital elevation model. In the output extent, choose this file, that is the export feature. Now this is important to use, that is this one. You need to check this.
Okay.
Okay. Now if you don't check this, what will it do? Now I want it just in this shape. If I
Mm.
don't check this, it will give me a rectangle with
Mm.
the endpoints of it. So I don't want that rectangle, I want the proper shape. So
Mm.
for that I will check this. Now when I click this run, and I turn off the other one. So
mm,
I have it clipped for my region. So if someone asks me, I can tell the highest point in this district is 294
mm,
and the lowest point is 235.
yes.
Okay. So uh, in your black area, is any other polygon also falling completely?
Let me check. Mm, not, no, 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 no. No, just a half for the all the other ones are half. This is the full.
Okay. Now do one thing. If it
Mm,
is half,
mm,
try to do just select this,
mm.
export this, and then try to clip the raster with this and see it will just clip this half.
Half, yes, okay.
Yeah, just do it and let me know once you're done.
Okay. Done.
So, were you able to do it?
Yes.
Yeah. So, now you know the clip raster function.
Yes.
Now, what if I uh, give you two polygons? Hmm,
Yes.
let me explain. Okay, maybe. Hmm, So, for example, this blue part is your uh, illegal illegally constructed area.
Mm,
Okay. And the red zone is the forest area.
mm,
Now your boss asks you, give me a shapefile for the area which is which is illegally constructed and falls in the forest area.
okay.
So what would it be?
I've been used a clip like from the red one to clip it the blue one, and I get this area that's fallen inside the red one.
Yeah. So that operation is called as, because now we are working with polygons.
Mm,
So clip is more like extracting something out, that is
mm,
used in reference more to raster. You can clip also from a vector also, but in this particular case, if I was maybe, if this blue one is the illegally built area
mm,
and this one was the forest area, and my boss says find out the illegally built area file, so that would be equal to this one. So basically what I would do was I would either just give it directly to him or clip the below one. But
mm.
clip is more used for rasters, not for vectors. Because in
Okay.
vectors, you understand, if someone wants this, you can just directly give him this.
Mm,
There's no need to clip it.
yes, I just exactly, yes.
So, whereas in, so the particular case when you have this and this, the region your boss is asking for is this region, that he
Mm,
wants a shapefile of this region.
this thing, yes.
So how will you do it? In that case, it is called as intersect.
Mm. A vector case.
Yeah. So for example, just remove all of it. Now, for example, mm, create shapefile. Just go to the view, click on view, click on catalog pane, go to dataset, databases. On your database, right click, create new feature class. In feature class, call it, I will call it ILBA, that is illegally built area, and just finish it. Select polygon, don't forget to choose polygon and click
Okay.
finish. And then maybe right click, go to new feature class and write forest. So in forest, select polygon and finish. Now you have two shape files here.
Mm,
Go to illegally built, click edit, go to create, select the, now just create a polygon somewhere. That is your illegally built area.
mm,
Also select the Mm. After this, just select this and then select forest.
Mm.
Also create, just overlap it somewhere. Then click save.
Mm.
Done till here.
Yes.
So just drag one over the other and see how it overlaps it.
Mm.
Now what you do is we go to analysis again, go to tools and right here intersect. You choose this first one. So because it's a vector, it doesn't mean the chronology of choosing because just choose these two, turn this off, name it as you want and click run. So now you have the common area.
Yes.
So you know now clip, you know
Mm.
intersect. So they are one of the two basic operations of vector as well as clip is used in raster also. Hello.
Yes, yes.
Okay. So now we will do, maybe I'll not remove it. Okay. Will Asad will take like a 4 minute break.
Okay.
I'll be back at 40
Okay.
and you can maybe just try experimenting with looking at maybe creating another two polygons and try to intersect, right?
Okay.
Uh, रवैया देखते हैं कि इस लड़की के साथ सुसाइड मेरा बोल देना था बता तो कहानी को यही से वही रखता हूँ वहाँ उसके बाद बैठता हूँ और सब करती है एक काम कर सकते हो तो कर लेना, क्यों ना एक बार में एक आध एक बार में चार जी को कॉल करके देखना और एक पूछ लेना क्या देखना छोड़ क्या। तो एक ना मेरा ये पूछ के देखना कि यार लेना ठीक। हाँ, okay. Uh, were you able to, did you try another one? Hello.
Hello, yes, I tried to do that.
Okay. Now, what we will do next is, uh, take any zone that is having river. Look for any river. Mm. Maybe it is not so visible in this. Go to map, in
Mhm.
base map, select the other imagery. Okay, it is not even that is even there. Maybe
Can
select,
we also do that the same in QGIS as well?
yeah.
Okay.
You want to talk, you are seeing this clip and everything, right?
Yes, yes, yes.
Yes, yes. You just go to QGIS, there is toolbar, you select it and you can do it. Now, I will select in base map, I'm selecting OpenStreetMap.
Mhm.
So when you choose OpenStreetMap, here look for Manali maybe. Just look for any place where you can find the river. Hmm. Okay, so I have this Mandi area and this river is flowing here. So have you found out some area
Yes.
where you see this blue thing?
It's not exactly it's a blue. Yes, but I don't remember know the name.
No, no, name is not. If you zoom into it, the name is written there.
It's Yamuna.
Yamuna, yeah.
Yamuna.
So, is it like not going straight, right? It is
Yes,
moving
it
like,
also has kind of different structure, not a straight one, yes.
okay.
S shaped or something like this.
So when you go to, just go to, again go to view, hit the log pane,
Mm,
select new
mm,
feature class, call it river,
okay,
but this time select line
line.
and press
Okay.
finish. So after selecting river, just go to edit, create,
Mm,
select the river. Now I will make it random, like no need to be very precise, but just make it random.
okay.
Mm, Then save it.
Okay.
So you just made some random area. Uh, I mean, I just made some like randomly the river.
Done. Yes.
Now it has.
Perfect ID.
Now what I'm doing, just click here.
Mm,
I will make the size bigger or change the color to a river only so that I can see it from here. Then I click. So I know now the river. It is looking like this. Now you know the river, and for example, there are some buildings here, right? There must be buildings here. People, this is a city. People must be living, right? Now
mm,
someone tells you create a flood zone with the 100-meter as high risk zone, 200-meter as moderate risk zone, and 300-meter as low risk zone. Uh, right?
yeah.
So what you will do is you will go to analysis, tools again. So you look for buffer here. Just click on buffer, select river, put the value as maybe let's try. Okay, let's put the value as 100 only. Right? Now select run. Okay, this is something wrong. Ah, so what happened wrong was just delete this river buffer. So here in decimal degree, select meters if you find meters. Select meters, right?
Yes.
So change the name a little because river buffer was already created. Just make river buffer 1. Now when you press run, you have a coverage of 100 meters. So now you see these buildings below. You can make a map saying that this region is in high flood risk, right? Hello.
Yes, yes.
So then maybe select river buffer, call it river buffer 200. Select 200 here and then run. Then make a third one, call it river buffer 300. and make a third one and run. So now I have three. Now let me change the color. In one I will call it green. In another one I will call it maybe red.
Mm,
Now place the river buffer 1 above, then the river buffer 200. Now you can see the zones here, right?
mm,
This zone is the high flood risk zone.
mm,
This is moderate flood risk
mm,
zone. And this is low flood risk zone. So
yes.
now you understand how to use buffer.
Mm,
Okay. Then what you do next is Mhm. Now because when I close this, there is this low risk zone is present all over.
mm,
So if I want the area of the low risk, this all is not low risk. This area minus this area is low risk, right?
yes.
So I just want this outside one.
Mm,
So what I will do is
intersect.
I will do kind of intersect only, but this is not exactly intersect. Intersect will give me the inside area, but uh, in intersect there is one another option that is called as when I select intersect, I select the there's no option. Okay, let me select it first. So that is river 200 and river 300. Click on the top here on pairwise. Pairwise. Mm, yeah. So it is called as erase tool. So in this, I will choose the refer buffer 300. I want to delete the part that is river buffer 200, right?
Yes.
When I click this, so if you see, I just have.
Mm, the other part.
So similarly for river buffer 200,
Mm,
and I will delete from that the river buffer 1.
mm,
So I have this,
mm,
and river buffer I have this. So now I have the exact
mm,
demarcation of
mm,
my zones, right?
yes.
So we have, when we are working with more than one thing, that is one shapefile, that is called overlay analysis. So,
Mm,
for example, we were working with intersect, right? So, for intersect, you need to have two files, two vector files. So, in clip also, you need to have two files. Whenever you have two files, it is called as overlay analysis because you are placing one above the another to do some kind of analysis, right?
mm,
So, for example, you have different kind of, just as I showed you digital elevation model today. Similarly, if you have slope, raster, stream buffer, or combination of layers,
mm,
and you use them together
mm,
to do some analysis, and you come out with these. So it is kind of overlay analysis.
mm,
Now, when you are doing vector-based overlay, it can be of three type. One is point in area,
mm,
also known as point in polygon. The other one is line in area, also known as line in polygon. Then we have area on area, known as polygon on polygon. What it means is, so we'll do the first one, that is
pointing.
point in area. Now you have 3 points. A is elm tree, B is
Mm,
maple tree, C is elm tree.
mm,
And you have these three trees, and in the same region, you know that this half of the region, left side, is a village, is a rural
mm,
region, and on the other side is the urban village, urban region, sorry, urban region, a city. So now when I do overlay analysis and I combine this, now every feature has got more data now. Now I know that A is elm tree and also it forms lies
covering.
in the rural area.
Yes. Yes.
So similarly, so this analysis is like I have point and then a polygon. Then I
Mm,
derived the result based on the point in polygon overlay.
mm, yes.
Then if you want to look on line in polygon overlay, for example, this is some these are some roads, right?
Mm,
So just ignore this. Maybe these are some roads, and these roads are falling in this region. So now you know that C and B are completely in urban, whereas
mm,
whereas A and D, sorry, whereas A is in rural area.
mm,
So you got extra information. So this is the line. It was the line that was uh, the information added was based on the polygon. So line in polygon. Similarly, you have
it
polygon in polygon.
overlays override in both areas or
Pardon?
combine both areas.
Port areas?
No, no. So it combined the both areas like streets and then cover, and then it create a new one.
Yeah, yeah.
Mm,
So now, for example, if I have polygon on polygon overlay.
mm,
Now you see here, this was the province. For example, these are three different cities. Okay.
mm,
And this is
yeah,
the different land use. For example, A is built up, B is forest, C is um, plantation,
mm,
something, D is something. Now, when you combine these regions, now you see that, for example, A was built up.
mm,
Uh, so now you know that some region of 2, some region of 3, some region of 1 lies in A that was built up.
Mm,
So basically what it means is, look here, now it is divided into more numbers. Now when you
mm,
take this 5 for reference, like I take this 5,
mm,
what 5 means is that it is from province 3, this is
mm,
from province 3 and is
nine,
currently having this land use.
mm,
So this is polygon in polygon analysis. So in simple terms, it is basically this 1 by 2 a plus b, it forms this.
mm, two.
So we did some of it. We did intersection, right?
Intersect is
We did clip.
clip.
So we did buffer. So these are the some of the vector overlay options or some of the vector overlay features that you can try. So you can do is one thing that as a homework, I'm not going to check, but for your own clarity, you just do all of them. You have to just, the way we searched intersect, similarly, just go to tools and you have to search each here.
Union.
So this will show up, make some random polygons,
Mm,
try to see what's the difference, try to make
mm,
them out. Now, there is this. So particularly in intersect, what we do is two polygons, the common part comes out.
mm,
Then we have the erase tool. So if you want the part other than the intersect, so I erased this from this one.
mm,
Similarly, for intersect, it was like if they are two files, so intersection would be this area.
mm,
Now there is union. So in union, what happens when you like these are two different files, when it makes a new file, it preserves the original boundaries.
mm,
What is merge tool? That is you're adding one to another. So you see there is no boundary here.
mm,
Whereas in append, like this is shapefile 1, this is shapefile 2, it will form a new shapefile 3. Whereas in append, you are in shapefile 1 adding shapefile 2, that is you're modifying shapefile 1. So this will get deleted and this is now the new shapefile 1.
okay.
Basically, you are adding this data to this
Into
data.
that is
So here it is, he has done the reverse. He has added dataset 1 to dataset 2 and it forms the dataset 2, right?
yes.
So similarly, we have this in, this is a comparison of what we do in vector and similarly what we can do in raster.
Mm,
Mm, Just a moment. Have you performed any, like until now in your studies, have you been doing any kind of raster analysis?
yes.
What have you been doing?
Uh, it's kind of like kind of assignment stuff. Like I have to find different land use cover something. But I don't remember like the exact thing.
Mm-hmm.
But I have done something like sun analysis, like to find out the. I don't remember the name of this. It's a kind of stuff, but it's not a raster, I guess. But what you can say this, how we can install the solar panel and what is the best suited site to install the solar panel in that region.
Ah, nice project. So, what are the different kind of input layers they have provided?
I guess I, I just forgot someone. It's like I have what I have like found the heat up areas first,
Mm-hmm.
and then found the sun angles as well. Like which is the best? First I found the building's height. Like okay, so where does the sun comes, and then I found the sun angle, like from one to one, which areas will be more suited for the installation of solar projects. And then I guess what else? Based on these analysis, we find that okay, these are the probabilities. Okay, if we installed solar panels in that buildings, do we have the benefits, or if or we don't have the benefits because of the building heights and the sun angles as well.
Okay. So, how have you been able to find that sun angle thing?
I guess the professor like gives us the it's on online data set that provided by the EZ or something, and we use that data sets.
Okay, 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 okay. So maybe you could do one thing is if possible, share with me the data if you have anything. Not
Okay,
now, maybe later. We'll just try to maybe figure out or create an exercise with that kind of data.
okay. Perfect.
And can you name me the subjects that you are studying? All the subjects.
Uh, I haven't missed. Then I guess it's spatial analysis. I don't remember the
Okay,
because it's done in the previous semester. Okay.
okay. And what other than that?
Spatial analysis, and then right now I'm doing GI theory and science. It's kind of a seminar one where we have to discuss papers, and then at the end of the semester, I have also do a presentation and write a paper as well. And then I have like uh, cartography and geomedia, that's in German one, and I have to study on my own. Okay, apart from this, book cartography,
Hmm.
and what else? OpenGIS and standards, and what else? This is the one method in spatial analysis, and then right now I answer doing the design of geospatial data models,
Mm-hmm.
and then scientific methods and writing, and these are the stuffs. Yeah, these are the courses I've taken.
Okay, okay.
But
So,
it's up to you, like how many subjects you choose, how you want to plan your studies. Yeah, you are fully independent. You don't have to depend on the course. I mean, you have to complete the course curriculum, but it's not fixed that in every semester you have to do like 30 CDs or 40 CDs. It's up to you. It's on your choice how you want to study.
yes. So you are a self-funded student, but are you studying the same course as the Erasmus, right?
Yes, in the plus, it's kind of a similar one. In this University of Salzburg, it's similar one. But if
No, no. Are you a Erasmus student, or did you enroll with the Erasmus portal, or you're just the
no, I'm
Salzburg?
just a regular student of University of Salzburg, not the Erasmus one. Like
Okay.
most of the students also come here, but they have different fields like geodata science and geovisualization.
No,
For
no. What I
geodata
want to
science,
say is like it is better to be a normal student than Erasmus because
yes.
in normal student is like you can extend your degrees more than two
Hmm.
years.
Yes, that's what I'm talking about. Like I was independent of ACTS. I don't have to worry about, okay, in this semester I have to done 30 ACTS or 40 ACTS.
Okay. And this, like, you can extend, like in Germany, you can extend to 4 to 5 years.
Mm.
So is it same as?
Yes, I guess it's same in Salzburg as well.
And the main thing in Germany was this, there were no written exams, only assignments. What about that?
No, no, here it's a combination of both. Some of them I have to present, some of
Hmm.
them I have exams, some of them I have like lecture based, and then at the end I have to like summarize or what you can say this. Like they give me a project at the start of the uh, course, and then I have to work alone. If I face some issues, I can ask the professors, and then at the end I have to like give a full presentation and full overview of my project with documentation, like what I have learned, what I have to do, what my aim was, and stuff like that. It's a complete whole one. And some of them are like assignment based as well. They just give 3 or 4 assignments, one in the start, one in the middle, and then at the end it's a full project type of assignment.
Okay, okay, okay.
It's a combination of both practical plus lectures as well.
Got the point. Okay, then. Now, since we now you understand now until this the vector overlay part is complete. Now you understand what a vector overlay is, right?
Yes, yes, yes.
Uh, so here in this slide, you can see is a analogy of raster overlay as well as vector overlay. So
Mm,
we have presented both vector as well as raster for you to compare and understand the similarity among the both.
mm,
Now, in one that is the above case, now you see at this image, for example, this is a polygon with zero value,
mm,
right? And this is a polygon with two value. Now, uh, when you add this polygon to this polygon, the three will be preserved. Now 2 plus 0 that changes to 2 and 3 plus 2 it changes to 5. Hello.
yes.
So it is something similar to polygon and polygon that you kind
Mm,
of from
I
two
think that.
polygons you got polygon polygon, right?
Mm,
But the operation you applied here was addition.
mm,
So in this case it was more like understanding the region better. But in this particular case, what we applied the to get an understanding, we applied ourselves the addition operation.
mm,
So this is also part of overlay, right?
mm.
So
Yes.
for example, if you have a image with the pixel value here as 2 and another image with the pixel value here as 3. Now you apply this overlay operation. So what you will get is this. So just to look, you can get to understand the similarity of the process. Okay.
Mm,
Similarly, here in point and polygon, you had these four maybe trees and you have a region. So out of this, you can see and analyze from here because these two fall into the polygon, whereas these are out of it. Now, what you do is you took an image with the pixel value 1 here, and you have this image where the pixel value of tree is 3.
mm,
So when you will add, you will see this image is the output. Now, if you extract the values where the value is 4, it means 3 plus 1. That is, both conditions are satisfied. That is the places that. So now we know there are two places in these pixels where it is 4.
mm,
So that means 2 points are trees in that area.
mm.
So similarity, right?
Yes.
Then we have this. Uh, just imagine one. This is your one image with these pixel values,
Mm,
and this is your another image with these pixel values.
mm.
Now you apply the addition operation and you get this
Yes.
3 plus 2, 5.
Five, yes.
Yeah. So similarly, there is other. Instead of addition, you apply subtraction.
Yes.
You will get this.
Mm,
Now you select an operation where you want the value, the maximum one only. So 3, 3 from here.
mm,
So it will
mm,
select, compare the pixel and only select the maximum value.
yes.
Similarly, minimum
Mm,
and similarly average. Now you can also apply more conditions to it. For example, you want that the pixel value in layer 1,
mm,
it should be greater than 2, wherever it is greater than 2, and also the layer 2, the pixel value should be greater than 1.
mm,
So you applied a condition. So whenever we apply a condition in which equal to or greater than or less than is used, it is called a Boolean condition.
yes.
So what it means is either it is true or
Mm,
it is false.
false. Yes.
So in case it is true, we use 1 for true, that it means it is true, and 0 as false. Now, like here in this pixel, it is greater than 2. Similarly, in layer 2 for this pixel, it is greater than 1 because it is AND. So the
Mm,
condition should be satisfied in both. So it was 1 here. But for
yes.
any other pixel, the condition is not being satisfied. Hence it is 0.
Mm,
Similarly, in this case, because it is OR, we are able to get more ones because
mm,
either it says either layer 1 is greater than 2, so it is at so many places, or it says it is greater than 1 here. So it is also at so many places here, right? So when you
yes.
look at this, this comes as the output of this, right?
Yes.
Now, then we have raster data processing models. So there are three kind of raster data processing models methods. One is local operation, another one is neighborhood operation, third one is regional operation. Now, for example, you have this. I explained this with where is the lecture today? So, for example, define a new class. I tell my computer, you have a image, you have different pixel values, So maybe here the value is 0.33. Maybe here the value is minus zero point 0.5. So each pixel has a different value based on the NDVI, right? If this is a NDVI image, right?
Hmm.
You understand that part, right?
Yes, yes.
Now I want to reclassify the pixel values. I am not concerned about these values, whereas my objective is to define a class. For
Hmm.
example, maybe I say a very healthy plant is class 1, this
Hmm.
is class 2, this is class 3, and this is class 4.
Hmm.
So I apply an operation on this image where the values between minus and 0 are converted to 4
Oh, yes.
and the values here are converted to 3.
Hmm.
So my final image will have only these four value 1, 2, 3, 4. So
Yes.
that is the class. Now I
Hmm.
will click here and I know if it is a healthy plant because I'm not concerned about the raw values. I just wanted class.
Yes.
So if I click somewhere and it turns out to be 3, so it means unhealthy plant,
Hmm.
right?
Yes.
So this is local processing. That is you you are applying a rule set, but on each pixel.
Hmm.
On a single pixel, you are saying that this pixel falls into this category. I want this to define a class. So the surrounding pixels do not have a say on the character of the particular pixel. It is defined by the rule of table that you input.
Hmm.
So this is called as uh, this is called as reclassification. So these were the old values. You selected the new
Hmm.
values.
Hmm.
This raster is changed into this raster.
Hmm. So does the pixels can also be enhanced in this one, or it's just the values?
Hmm?
So the pixel values is also like the image become more clear or better, or it's just the values
No,
like
no. The image is more clear when it had more variability. Now the image quality will decrease
mm,
because I'm not concerned about how the image looks
yes.
because I just want my data to have four classes. I'm no longer kind of uh, I earlier had a NDVI image.
Mm,
What I want to extract from it is that when I click on any pixel, I just want to know if it is a dead plant
mm,
or any
mm,
plant. I don't care
mm,
how it looks now.
mm,
So
got it.
it will not look so good as it was before, but I don't
Mm,
care about it.
mm. I just
Right?
want to get the full values out of it.
Yeah.
Mm,
So that was my particular case. For
mm,
example, if you want to reclassify it into uh, more values, maybe. For example, if you do the reverse of it, you you take this on the left
mm,
and bring this on the right.
mm,
So if this was maybe 1 to 20 and you reclassify it to 1 to 60,
mm,
earlier what was it was 21 to 20 and we classified it to 1 to 5. But for example, if you just had an image that is 1 to 5, just take it in the reverse order. So you had 1 to 5, you reclassified it into this. So the quality will increase. But in
mm,
that case also it is called as a reclassification only.
mm.
So it depends on your use case, how you want to use it.
Mm,
For example, your purpose was to get a more clear image, more
mm,
detailed description, then why not?
yes.
So this is not a part of raster. It is just to understand. Uh,
Mathematical application.
this is just to understand this thing.
Mm,
And or so
yes.
A X B if uh,
One condition is true, then yes, both will be added.
oh, no, no. Okay, sorry. This is raster only. What I did wrong was, yeah. Now you have two rasters, two
Mm,
different images, and or two different polygons. Okay, and
yes.
you it can be vector also, not necessarily raster only. Now you
Mm,
place them like this, right? And I tell
yes.
you A and B condition where A and B both are satisfied. A is
Mm,
also true, B is also true.
mm,
So that would be this area, right?
yes, yes, yes.
Now I say A or B. Either A is
Both.
true or B is true, I don't care, but one should be true.
Mm,
So this will form this area, right?
yes.
Now I say A should be true, but B should not be true.
Mm,
So in this jurisdiction of A, in this part, B was true.
yes.
So it removed it and it is called as this.
A minus B.
Now this, neither A should be true. Oh, sorry. Uh, this is more like A and B together should not be true.
Mm,
So you can think of this like if you
yeah.
remember A or B, it
Mm,
is either this,
or
either
this.
this. A, XOR B, neither this, neither this.
Mm,
So neither A, neither B should
another
be
B,
true.
another this one, yes.
Yeah. So sometimes the question comes in this terms down here,
Mm,
or it can come create. You will be given two polygons. Create a output result for A XOR B.
mm,
So this is also similar. So in the keyboard, yeah, right. So these all are Boolean operations, right?
yes.
Because it is based on whether the thing is true or false here. So it is Boolean. Now, when you are working in raster calculator, if you are applying two rasters, so these are the symbols A and
Mm,
B. A or B is this
or
symbol.
B.
A XOR B is this symbol.
This
A not
mm,
B is this symbol.
mm,
Now we are done with local operation, right? What
yes.
local operation basically meant was that when you are reclassifying in your system of reclassification, only the pixel value matters and the
Mm,
rule matters. Now 11 is 5 because of this table. There is no interference of the pixels around it in its new value.
yes.
So that is why it was local operation. Now we
Okay.
are going to talk about neighborhood operation,
Mm,
where the neighborhood has a say into what is happening with the final value.
mm. So, oh, so basic that.
Just a moment.
Yes, please. Hello.
Just a moment, just a moment.
Okay.
Yeah. So now, for example, I here I had a table. Now I define a rule of law where I say that the new value could be addition of all the previous values to your current value,
Mm,
of all the neighborhood values to your current value. It could be addition, subtraction, multiplication. I could change the rule as per my requirement.
yes.
So this new value of the pixel
Mm,
is dependent on the neighbors.
dollars.
There are different kind of operations. Uh, the name is like, yeah, nearest neighborhood or
Me.
so they are maybe called as near neighborhood, nearest neighborhood, or there is one thing called as IDW. So it can be, it is also something that is based on your uh, neighborhood
Pixel.
values. So there are many that will maybe come across our way.
Mm,
So for example, I assign weight, I assign a preference
mm,
that the value of the pixel adjacent in this direction, this will influence it more. So that,
mm,
for example, it influences this 80% and the rest have a just 20% influence. So
mm,
whatever the value of this is into the 80% and add to it. And
mm,
whatever the value is here together into 0.20 and then add to it. So I can make the rule as complex I want. I can change the rule anyhow, but the main condition that is that the value of the new pixel is or the new class is defined on the like neighborhood, right?
yes.
This is a similar image only.
Mm,
So then you have
mm,
regional operators. Uh, what that means is simple operations like plus, minus, multiply, that is regional operators.
mhm,
No, no, sorry. Region, yeah. Regional operator means is more of like what if you remember what we studied here that there are two different kind of regions. When you phase them out, you have four kind of data, right?
mm,
You have like subdivisions to understand the things better.
mm,
Similarly, in regional operations, you have, for example, here there are two kind of data in regional operations. So if I have one data that says maybe this area is green, that is forest, this area is built up, this area is school. Okay.
mm, mm,
Now I have defined the zones where I want to do my observation. And I have taken the rest zone, maybe zero or something else, but a homogeneous value, right?
mm,
Now, there is another raster which has maybe, for example, this is NDVI, or this may be the uh, pollution over the area.
mm,
Okay. Now, when I combine this, I have this phased out. Now I know the pixels in the school. I can say the forest maybe. Now I can average it out. I can say the forest area has this much pollution. So you are using two rasters. One raster defines the boundary of your area of observation, and the
Mm.
another raster defines the value. Understood?
Yes.
So this example is a little bit difficult to understand. Mm, I will give you another example of this, but this one is something wrong here. What you could do to understand this is, yeah, it could be better understood with this one. Now, for example, this was a raster where this defined the boundary of the forest area.
Mm.
Okay. And we have values. So, for example, maybe all of this had value. Uh, just say it all had maybe value 1. All of them had value 1. Where it was value 3, it means there is a cement patch. Just assume. Okay. So, now in your defined area in a raster, when there applied was an operation, and now you can figure out with the new raster values, you can analyze it out. You see that in your, sorry, your boundary was from here. In your boundary area, there are two pixel values that are unique. So
Mm.
that define the, so what you've done is you have preserved the boundary and added the value. This is a
Mm.
little complex to understand, but do not worry, this will not come anywhere for you to tackle technically. What,
Mm.
pardon? Hello?
Yes, yes.
So what you mostly would be doing is addition, subtraction, and things like this.
Mm.
So
So what's the use case of these examples? Like
this is
specifically?
to understand raster operations. So when you are working with two rasters and
Mm.
you analyze them together to, like we created an NDVI based on two rasters.
Mm.
So we used plus minus. So that was overlays, raster overlay. So we took pixel values and applied some operations between two pixel values of two rasters.
Mm.
Understood?
Somehow, yeah. Because it's very getting very confusing in these scenarios. Like I knew the addition, subtraction, raster reclassification, but it's something very new.
So this is what you have been doing, but this is the theory part of it. Like,
Mm.
for example, what you did was, mm, so this is band 4
Mm.
and this is band 8
Yes.
of Sentinel-2.
Yes.
So you have this image.
Mm.
This is red band. This is NIR band.
Mm.
So these band are just like matrices. All of them have pixel values.
Mm.
You have values here. So you have values at each point. So for example, you have maybe 4 here, you have 10 here. So what you did when you were taking out NDVI, what you did was for you did band 8 minus band 4,
Yes.
band 8 plus
Yes.
band 4.
Yes.
So what you basically did is these are two rasters. You
Mm.
were analyzing their pixels. So if I
Mm.
just do band 8 plus band 4, maybe just I do band 8 minus band 4. So I
Mm.
will get one raster.
Yes.
And if I do, so just think this is band 8 plus 4. So
Mm.
I added all the pixel values of this to this and made
Mm.
one. And then I did one another, that is value of this minus
Mm.
this. So it will
Mm.
give me another
Yes.
one, that would be 8 minus 4. Now what
Yes.
I did was I divided.
Divided it. Yes.
So basically I'm just doing operation uh, on the pixel values. That is that is overlays. That is,
Mm.
now you understand what overlays is.
Yes. Yes. Yes.
So what you were doing is this only, but this is the theory of it.
Mm. Okay.
So now we know the uh, different kind of overlays. We know the vector overlays, we know the raster overlays.
Yes.
Now, what you do is we have class on Sunday now.
Yes.
So are you busy tomorrow or what are you doing?
Uh, Maybe next week can we adjust the timing because this
No,
week
no,
I
no. I'm just asking like if I have to give you some assignment or homework.
yeah, I will try to do that on before Sunday class. What's that?
Okay, okay. Then do one thing is,
Mhm.
did we make any map before?
Uh, just a NDVI, something like that, but
No, no.
not.
Did we make a map, proper map?
No.
Okay, so we did not did a map class in QGS, how to make a map.
But this is just a general one, not like a present and not 2D. But I knew that.
No, no. Have we done a class about me teaching you how to make a map in QGS?
Don't think so. We just used the how to add the data, and after that we just do the NDVI, and
Oh, okay.
yeah, yes, these are the two steps that we have done on
Okay.
QGIS.
So in the next session, what we will do is,
Hmm.
before we start with maybe SQL and everything,
Hmm.
we will do that part of how to make a map.
Okay.
So because sometimes map is important, like people would ask you to create a map and you need to also make one in your thesis.
Hmm.
Or we can do one thing is we can create one right now.
Hmm.
Let me see. Let's see. So do you have your did you close this or do you still have it?
I have this.
Yeah. Now when you maybe select okay. Now when you go here in the insert
Yes.
and click new
New
layout,
layout. Yes.
maybe we select A4 and
Before.
landscape.
Yes.
So this has created a map interface.
Canvas. Yes.
Now what I'll do is I'll choose in the
Hmm.
map frame, I will choose this.
This one, yes.
And then I paste
Hmm.
it like
In
this.
QGIS, it's also the same thing, or
Uh, Almost the same.
because I didn't work on QGIS as well. I only work with ArcGIS Pro.
So maybe I'll just do it in ArcGIS today and we'll do it next time in QGIS.
Okay.
So now you see that
Hmm.
the uh,
Map.
area is visible.
Hmm.
Now there is this, when you go to layout, there is this activate.
Hmm.
If you
Then I
click,
can zoom in and zoom out, yes.
so you just make the
Hmm.
layer according to your reference and then in layout, you
Oh,
can close activation.
yes.
Then in layout, there is, sorry, not in layout, where
Insert.
yeah, in insert, there is north arrow.
Scale bar, yes,
You
everything.
can,
That's.
you can place one like
Hmm.
this. Then you have the scale bar.
Hmm.
Choose the appropriate one. If you want in kilometers, there must be one here in kilometers. Here. So, uh, you can put it here. So, I have a scale bar. Then, if you want the legend, that is the data that you have added, you can place it here. So, though river is not shown here, but if you drag the, okay, if I drag the rivers from the top one, so also there is grid. Where is grid? Labeling. So there is also one option that I'm not able to locate, that is to give the map grids.
Hmm. I don't know.
Huh?
I also don't know about that. Maybe in the layout option.
You can just have a look here.
Yes, in the layout. Go to insert tab. Layout.
Mm,
In
Let's see, so very inside.
maybe not table frame is not there. So
Now let's add the grade and coordinate values. So that we need to select the map frame and go to the insert and new grid.
Hmm.
Select this one. We have successfully added the grids and coordinate points, but we need to fix the spacing a little bit so that let's unlock our map frame and make it a little shorter so that we will create some room for the coordinate value. Now we want to remove the inside grid. We will only uh, allow the coordinate points and tick marks to label and tick, no inside the grid lines. For that, let's click on this grid, go to element, we need to select the components. From the component, let's click on the grid line and remove this. Grid lines have been removed.
So it's clear now, right?
Hmm. Yes.
We almost have a good map. So similarly, we can create one in QGIS. In QGIS also, it's very simple. We'll try to do one in QGIS next time, and then we will start with the SQL and everything.
Okay.
Uh, Maybe it is possible that I will teach something more raster and vector in next class. Maybe we will do the SQL from its next session.
Okay.
But let's see. Are there any things that you want to to cover, or you know of some topics that are not written in your curriculum?
Yeah, I was also thinking something, but again, I guess I forget it. I haven't tried to write it down, and then
Mm.
we will definitely let you know. Because I feel that, okay, these some things I knew that, but some of things I also don't. So it's better to refresh my knowledge again. So
Mm.
if I feel that, okay, if I was lacking something, I will definitely let you know.
Okay, okay. Then what we will try to do is we will kind of create a intensive NDVI map in
Mhm.
QGIS. Okay.
Okay, perfect.
Yeah, and this will maybe next session or from the next of it, we'll start with
Awesome.
SQL.
Okay.
Okay, then for we meet on Sunday. Sunday, what
Yes.
is the time of the class?
I guess for me it's 1, 2. Let me check it.
2:30 to 5:30. Okay. Okay
Yes,
then.
for me it's 10 to 1.
Okay then. See you on Sunday.
Okay, perfect. See you. Ciao.
Yeah.
Bye.
Bye.